Alright guys, welcome back. So if you go into your Minecraft saves folder, this one, and just pick a random world, you will see a file called level.dat. And if you open this, oh well, it looks like garbage. But if you rename it with a .gz file extension on the end, then you can decompress it in 7-zip. And it looks a lot better. Yeah, there's definitely some things we can recognize here, but there's also a lot of random characters that don't make much sense. So instead, let's open it in a hex editor. Okay, so here are the bytes, and we're going to convert it to a JSON. The whole thing is just one giant dictionary, so we'll start with the dictionary character. And then this first byte 08, it's a bit strange. We do the type of the value first, then the length of the key, then the key, then the actual value. So this first 08, it means our value is a type dictionary. Then we've got 2 bytes, which are the length of the key. In this case, it's 0, so it's an empty string. So we can add that in, and we know the value is a dictionary. Then the next 0A, which means the next value is also a dictionary. Then the length of the next key, in this case 4. So you can read 4 bytes and get the key of data. Then we know the value of the dictionary, so we'll add that in. Then we move on to this 03 byte. 03 means it's an integer. And then 1A for the key length. It's also a bit strange they're using 2 bytes for the length, which means keys could be up to like 65 kilobytes long. And if your key's that long, then you've probably got problems. But we'll read the key of 25 bytes and pop that in. And we know that the value is an integer, so we read 4 bytes, and that corresponds to 25. Move on to the next value type, which is 06. That's a double. Then the key and key length, and finally 8 bytes, which all resolve to 0, and 01, which is a single byte value type, then the key length and key, and then that single byte. And I mean, you get the idea, you carry on going, and eventually you get to a JSON that looks like this. Okay, so let's actually do this in code. We'll start by opening the file as a stream, and decompressing it using a gzip stream. Then we'll pass this deflated stream to our MBT reader. Sorry, I forgot to mention this whole file format's called MBT, hence MBT reader. Okay, so before we move on to MBT reader, we're going to make life a little bit easier. We're going to use generic dictionaries and generic lists, but instead of writing it out each time, we're going to have an alias of MBT compound and MBT list. And we'll write some extension methods on these. We'll use get, which gets a value from a dictionary with a given key and does an explicit typecast on it with the type provided. And then the same thing again, but it checks whether the key exists, and if it doesn't, it returns the default. And then the same thing on lists. And finally, we'll have a little enum, which specifies the different types of value you can have. Okay, so for our MBT reader, we'll start by reading the root. This is just a dictionary. So we'll get the type of the first value. And there's a strange edge case where the type of the first value might be an end tag, in which case there are no keys, so we just return the empty dictionary. Otherwise, we'll read the name of the key and read the value with the given type and assign it back to the dictionary using the key. Then finally, we can return it. Okay, so to read a string, first we read the length as a 2 byte short, and the short is signed, so we just do a sanity check to make sure it's greater than 0. Then we'll read that number of bytes from the stream and convert it to a UTF-8 string. Then to read a short, this is just reading 2 bytes from the stream, and it's stored in big endian. So if we're in a little endian environment, we reverse the array and then convert it to a 16-bit integer. Finally, we get to read value, and this is quite straightforward. We switch on the value type, and if it's a byte, then we read a byte. If it's a short, we read a short. And for all the other data types, we read those corresponding values. And if there's something we don't know about, we'll throw an exception. Reading longs is just like reading shorts, except we're reading 8 bytes. 1 byte, floats are the same, you get the idea. So we're just reading a certain number of bytes, reversing if we need to, and converting it. Okay, so now for compounds. It's a bit like reading a root, except we can have multiple keys. So we'll create a loop, and we'll read the type of the first value, And of course, if it's an end value, it means we reach the end of our dictionary, so we return. Otherwise, we'll read the key and read the value and assign it back to our dictionary and continue looping. MBT supports lists as well, and what's nice is that all values in the list must be of the same type, and that type is described by the first byte. Then we'll read the length of an integer, and there's a strange edge case where the type of the list might be type end, and in this case it's probably that the length is 0, so it doesn't know what type of the values are, so we'll just return an empty list here. Otherwise it will loop through, reading values and appending them to a list. And our final data type is an int array. I'm not sure why they didn't just spend an extra byte making it a more generic array like they do with lists, but it's quite straightforward. We read the length as a 4-byte integer again, loop through it, reading ints each time and assigning them back to the array. Okay, so now that we've read this file into memory, we can wrap it in a level class. So we'll pass this dictionary into the constructor and get the first key, which we know is called data. Then what we're going to do is for properties on the level, these are just going to be wrappers that read and write to the dictionary. Things like time and level name are quite straightforward. And the reason we want to do it this way, rather than converting to a concrete data type, is imagine we're reading a new version of the file and it's got property in there we don't know about. If we were to read it and then save it, any properties we don't know about will get deleted. But by storing them only in the underlying dictionaries, any values we don't know about will simply be ignored when we're reading them, and they'll be serialized properly when it comes to writing them. For more complex data types such as player, we'll have a backing variable, and then we'll have getters and setters like usual. In our getter, we'll check if our backing variable's already been initialized, and if it has, we'll return it. Otherwise, we'll check if our dictionary contains a player, and if it does, we'll construct it, passing a tree down to the constructor. Otherwise, return null. And then settings very similar. We'll set the backing variable to the value. And if we've explicitly set it as null, then we need to remove the key from the dictionary. Otherwise, we update the dictionary with the new value. Okay, so now for writing. And we'll start by writing the root. If we don't have any keys, then we simply write our end tag and return. Otherwise, if we have exactly one key, then we'll continue, and anything else will crash. So now we can get the first key and the first value, and we're going to use a value writer here. This is simply because we have to write the type of the value first, then the key length, then the key, then the value. So to save us looking up the type of value twice, we'll call getValueWriter once. It contains both the type of the value and a writer for the value itself. This will all make sense in a second, don't worry. So we start by writing the tag type, which we got on the writer. Then we write the key, including the key length. Then we use the value writer again to write the actual value. Okay, so what does getValueWriter look like? It's just a type switch on the value. If it's a compound, then we'll return a tuple, where the first value is a tag type of compound, and the second value is a function which writes a compound. Similarly for int, we return a tuple, where the first value is a tag type of int, and the second value is a function and writes an integer. And you get the idea. We just do the rest for all the other tag types. And if it's something we don't expect, then we crash. So to write an int array, it's just write the length as an integer and then loop through all the values and write them all as integers. To write a list, let me first check if we're dealing with an empty list and write the type as an end tag and the length as 0 and return. Otherwise, we'll get our value writer as before, write the underlying value type, then the length, and we'll for each the list and use the value writer to write all the values. But in it's quite straightforward. We get the bytes. If we're a little endian, then we reverse. Then we write our array, and that's literally it. Then for all the other numeric data types, it's literally the same thing. Write string's a little bit more complicated. We first convert the string to a byte array, then we write its length as a short, and then the array itself. And write compound, we'll go through each key, get our value writer as before, write the type of the value, then the key, then the value. Then finally we have to write an end tag to mark the dictionary as finished. So now we can read, parse and write MBT files. What can we do with it? I wrote a little wrapper class called world, which takes the save folder and parses the level out of it. So we can get the level, update the player's position, for example, and then save it again. It's literally that simple. And that's pretty much it. There is a lot more code than I've shown, so I've put it all up on a GitHub. So if you want to check it out, go ahead, link is in the description. But apart from that, take care guys, happy coding.